Okay, guys, we should be streaming. We should be live now. Let's see. Okay, I first want to quickly run through one article from Andreessen Horowitz, and then let's start actually building stuff. I've talked with a friend, and he suggested that we build NLLB in FairSec as opposed to GPT-NeoX, actually. I have to double check on the architectural details behind NLLB. Let me just see one thing. NLLB paper. Let me know if you guys can hear me well. I need to just double check the architecture. Is it encoder or decoder, or is it pure decoder? I forgot about that. The dense checkpoints. Encoder. Decoder. Okay. Let's see. Anyway, let me just paste the YouTube stream to Discord. Let me just quickly share this. Okay, we'll be going through this first. And then training 600 million checkpoints. So we're gonna start data collection. There is so many open questions. Like it's gonna be, I have no idea yet what we need to do to get this to run, but like I'm gonna create the GitHub repo as well. Okay, so steps for this stream. Go through the article. Are we using EncTech architecture? Start preparing some data and kick off 600M run. So those are the next steps. Okay. Okay. Let's quickly skim through this article. Curious to learn a bit more about some specifics about building a cluster. When does it make sense to build a cluster versus just rent, or just take a grant from Stability AI or Lion or something? I might be reading some parts out loud, but I can share I'm gonna share the link in the chat so you can open it up on your side as well if you want to. Going exponentially. Data center hardware and software. This means that we have a couple of players offering the cloud and then everybody else consuming. That's how I'm kind of interpreting these two curves. Correct me if I'm wrong. Okay, basically stating that initially it makes sense to obviously use the cloud providers, but then it starts eating on your margins. So you want to actually transition to potentially having your own infrastructure in-house, but it's hard to build those muscles once you're so used to using everything that the cloud is offering you. It's just a significant trade-off, okay? And then I don't know the Dropbox example. What happened with them, I'm not sure. Okay, those who have done this have reported significant cost savings. In 2017, Dropbox detailed in its S1 a whopping 71 million in cumulative savings over the 2 years prior to IPO due to their infrastructure optimization overhaul. Okay, nice. Repatriating workloads from public cloud. The calculus changes, okay? As growth often slows with scale, just how much market cap is being suppressed by the cloud, so we can help inform the decision-making framework on managing the infrastructure as company scale. Okay? To frame the discussion, potentially greater than $500 billion lost by the cloud companies. Are scaling companies can justify nearly any level of work that will help keep cloud costs low. The case of Dropbox and beyond. Shifting majority of their workloads from public cloud to lower cost, custom-built infra in co-location facilities, directly leased and operated by Dropbox. They increased the margins from 33 to 67%, which was primarily due to our infrastructure optimization and an increase in our revenue during the period. Nice. Okay, but that's just Dropbox. So to help generalize the potential savings from cloud repatriation. By the way, we'll start soon training. Let me just read this article. It's a very cool article. I pasted the link. Just some thinking about when you want to build a cluster versus rent. Repatriation results in 1/3 to 1/2 the cost of running equivalent workloads in the cloud. If you're operating at scale, the cost of cloud can at least double your infrastructure bill. So this is true even when you're not trying to train foundational models. This is just when you're running a SaaS or whatnot. %50 of the cost of revenue. How does one define cost of revenue? Okay. Makes sense? %81, wow. 75 to 80% of your costs come from cloud. Yeah, but still many companies wouldn't be able to do this unless they are super technical. Analyze committed cloud spend as a percentage. Palantir from Peter Thiel, Slack, Snowflake, Datadog, Asana. Nice. How much more? One rough proxy is to look at how the public markets value additional gross profit dollars. They are still burning cash are often valued on gross profit multiples. So for every dollar of gross profit saved, market caps rise on average 25x the net cost savings from cloud repatriation. Assume savings are expressed net of depreciation costs. Nice. This approach may underestimate the impact to market capitalization. Amazing. The paradox of the cloud. Okay, we're wrapping up this article. Where do we go from here? You're crazy if you don't start in the cloud, but you're also crazy if you stay on the cloud after you grow. So what can companies do to free themselves from this paradox? Part of making infrastructure a first-class metric. Interesting. Incentivize the engineers basically to fix some things and give them spot bonuses. Think about repatriation up front. Go hybrid. While these recommendations are focused on SaaS companies, okay, we are wrapping up the article and we'll start. How are you planning to get the compute? All of those are valid questions. I'm gonna tell you a bit more over the next days. I'm still figuring it out. There are some options I have. We'll see what's the best thing to do. We'll be addressing those questions today and tomorrow and over the next days. The 30% margin currently enjoyed and change the magnitude. Unlikely given that the majority of cloud spend is currently directed toward an oligopoly of three companies. And here's a bit of dramatic irony. Part of the reason Amazon, Google, and Microsoft presenting a combined $5 trillion market cap are all buffeted from the competition is that they have high profit margins driven in part by running their own infra. Cool. Okay, guys. Check out this article if you haven't. It's a cool, informative article. Now let's start figuring out some details. First, let's see whether, I forgot whether the NLLB architecture, the dense transformers, whether they're using decoder or encoder-decoder. For machine translation, historically it's been encoder-decoder, but let's just double check that that's indeed the case. Okay, seems this is the answer. Modeling. Our sequence-to-sequence multilingual machine translation model is based on the transformer encoder-decoder architecture. Prefixed with source language. Okay. Stacks of transformer layers. We apply a layer norm at the beginning of each sublayer, as opposed to applying layer norm after the residual connection at the end of each sublayer. This is because pre-LN is more stable compared to post-LN. Yeah, encoder-decoder attention, encoder-decoder architecture, and prefix encoder, and also prefix for the decoder. I think they, for encoder, they pass in the source language token, and for the decoder, they pass in the target language token. And cross attention. Okay, those are the standard stuff. Prefix. Okay. So I've been told that GPT-NeoX is not great if you are not using decoder only architecture. So unless we're willing to just stray and build our own new models, we should stick with PureStack apparently. Let's open up PureStack. Okay. Let's open up PureStack and let's see what we can do. Loris. Data. Okay. Let's download all of the data. And then we can start preparing the data. And then we can kick off a model run. I think for now we can just, let's try and just replicate without thinking whether this is going to be open source or not. That's going to be the first step. Let's just kind of build the muscles for using PureStack and training. And then I think we'll need to collaborate with Eleuther AI folks or Lion to help us with the navigate the landscape of open source licenses and tricks. They've been through it. They've been sued, some of them. I think they are even trying to reconstruct Pile because they are getting attacked even for Pile dataset. So we might be in the same trouble. Okay. Let's start here. Let me see, how do I stand with my why is this unmounted? 700 gigabytes. Okay, Why not focus only on a couple of on a subset of languages for now? And also, let's see what happened with the by text data. Did they ever release mined data? What is this? We decided to treat monolingual data similar to mined data, given that back translation and mining are both noisy sources of aligned data. Okay. Is CC matrix used in NLLB? Guys, can somebody check that for me? Let's see. NLLB paper. Let's just see whether they use CC matrix. Okay. All students were trained with the available byte texts in their respective language, complemented by 2 million sentences. teacher-student training. Okay, this is more for training the laser 3. We don't care about that. We use the CC matrix bytext directly for these languages. We then trained new sentence encoders and performed mining for the remaining 148 ones. Language-specific encoder training. Okay, this is the same thing. Okay. Yep. It's another very big mining data set. There is that one, and there is the wiki matrix. I'm just trying to figure out the details. What did they use? And why didn't they use CC matrix? Just trying to understand why they picked the data they did. Maybe let's kick off some of the downloads in the background. $22 GB for Turkish. Why didn't they use wiki matrix or CC matrix or any of those? And then preparing the data. I've done that already. Let's see whether these are mentioned. These are not even mentioned in the paper. Okay, none of these are mentioned. Okay, here is some public benchmarks. We use publicly available and widely used empty evaluation benchmarks to assess the performance on domains other than Wikimedia text of Flores 200 and to compare the performance to previous state-of-the-art. 8 benchmarks, 238 directions. Okay. Okay, summary of some of the main datasets used. Okay. Table 52, they summarize some of the main datasets used in training our model, largely downloaded via Opus and with the help of empty data tool. Direction counts refer to the number of directions used in this work, which may differ from the total number of directions made available by the corpus. Complete training configuration files are available in our repo. Is this a... Okay, it's broken link. I assume this is the one, this data here. Let's gonna cross compare. Let's compare this with what they've got here. We've got how many here? Is that like 21 here? And then they've got how many here? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 26 here. And they just say summary of some of the main data set. So that means they've used, yeah, this is definitely, we probably won't be able to exactly replicate, just there is a lot of ambiguities, I can already tell. Madar. There are 21 here, plus we know that they mentioned 3 more, so that's 24. So there are 3 more here. Three more here, plus 21 here. That's 24, and they have 26 here. Plus they say it's summary of some of the main datasets used. A lot of this data stems from this guy, Tiedemann. Okay. Yes, you're right. There will be 25. And then there is also the NLLB data. So that might be roughly it, but and maybe some of these functions call multiple. Okay. What's the size? How many? What's the expected storage? That's a useful piece of information, and I would also love to know why didn't they use any of the matrix, wiki matrix or CC matrix datasets. Let's just kind of skim through, see whether they mention something there. Okay, they did use CC matrix, but that's under the mining data, under the mining data. So they mined 148 byte text paired with English, 761 million sentences, and then byte text aligned with English for the remaining languages were taken from CC matrix. Okay. What about wiki matrix? Okay, they just mentioned it, but they did not use it. Okay. So, why not try and download, let me reopen that, sorry. Let me reopen just to see what's the size of the data set, or maybe if they mention it here, what's the cumulative size of this whole thing? How much storage do I need? I have a ton of storage. I have a I think I have a 6 terabyte SSD, although it's the setup protocol, not the NVMe. I also have the NVMe, but that's a smaller one for operating system and stuff. Again, let's just see. Terabyte. If somebody in parallel can take a look at can you find here the size, terabyte, gigabytes, size, just trying to understand the size of their primary data set. Okay, there's no mention. I doubt there is. We can't find the size there. Do we have this empty data thingy here? We don't, so that means something changed. Let's see the size. Or maybe they won't, maybe they'll just say the number of sentences they're using, and then we can kind of roughly estimate what's the average sentence length, which is hard to do across multiple languages, but could be a good estimate, good rough estimate. This will be valuable to read as well. We train a baseline dense encoder decoder, 1.3 billion. Okay, this is just experimental, potentially maybe on ablations. What's this? Limited size. Which is the same size as public byte text. Composition in figure 22. Table 24. Training size. Okay, so they go up to 3.3 billion and then they go to sparsely gated mixture of experts. We already knew that. Okay. I don't think we'll find. I don't think we'll find the solution here. Million sentences. Let's see whether they mentioned the number of sentences, maybe. Just lower down the shaders. Okay. Two million sentences. We mined 148 byte text paired with English text, which totals to 761 million sentence pairs. Okay. With English for the remaining languages were taken from CC matrix. Okay, we already read that. So 761 million sentences. How many is... Okay. This corresponds to 302 million sentence pairs. So around billion sentence pairs only for... Obviously we won't need that to train smaller checkpoints. Ranking from 39 to 18.7 sentence pairs. Okay. And that's the ablation data set. Okay, and let's see billion. Is billion mentioned? We started with 107 billion paragraphs from the web. Okay, that's for the mining, I assume. $43.7 billion monolingual sentences. Billions of sentences from the web. Okay, they say these contributions combined to create over 1.1 billion new sentence pairs for training data for 148 languages. This is the conclusion for which section? For mining. Okay. Over 1.1 billion new sentence pairs for training. That's conclusion. Okay. Okay, we've seen this already. I know this is optimistic, but might be worth to ask whether they're planning on releasing the mined data just to compare. Just double check that. Oh my god. All my videos are ranking first in Google search for NLLB. Interesting. Let's see whether... See you later, Yohit. I'm not sure how to pronounce your name, sorry. 450 gigabyte training data. Let's see whether... I'm all around the Google. Lohit. Okay. Interesting. Okay, NLLB from LNAI. What's this? Aha! Nice! It seems that the folks from LNAI Institute have released something. That's fun. Let's see what's up here. Okay, guys. Based on metadata. Mined by text metadata are open sourced in Laser. How didn't I see that? Where is the metadata in Laser? Okay. Where exactly? Data? Okay, NLLB 200. Oh my god, I forgot about this. Nice. As part of the project, we have mine, blah blah. This document contains metadata information for reconstructing these bytexts. The metadata files are space separated. Awesome, awesome, awesome. This is cool. Okay, we haven't gone through this when we were playing with laser. We kind of skipped this part. Okay, so apparently, we just put this into Notion. Okay, let's see what's going on. Let's quickly skim through the... Then let me just delete this issue. How can I close it or delete? Can I delete the issue or do I have to... Okay, I have to close the issue. Just for others who might encounter this. Close. Okay. Let's go through this. What's up with these directions? What do we have here? Is it like... Okay, it's a metadata information. Cancel. Thanks. But they already released the metadata. They will certainly not share the dataset themselves. Yep. Okay. The metadata files are space separated. XT compressed files. Each file corresponds to one bytext direction. For example, the file, this one contains all the metadata required to find the actual aligned text data. Each line has 11 columns with the following format. If it comes from the common crawl, then this, line number in document. Okay, but like the thing is, if you didn't reconstruct this on time, then things change, right? So who knows if you can still reconstruct it based on this information, because the content is not static. Well, you can maybe you can find some older dumps. Okay. Based on metadata information retrieved from standard input, wet lines will download the corpora, find the paragraph, and print the input with an additional column which corresponds to the text of paragraph. In order to retrieve one can use sentence splitter available here. You will print the input with an additional column which corresponds to the text of the sentence. Reconstructing sentences from metadata. Okay. They are releasing the metadata in the script under non-commercial license, of course. The text and copyright, where applicable, remains with the original authors or publishers. Please adhere to the applicable licenses provided by the original authors. We keep track of the source URL of each individual sentence to allow people to refer to said website for licensing information. Okay. Fair enough. Now let's see here. Was created based on the web metadata for mined by text released by Meta. Non-English language pairs using the Stopes mining library and the laser. Complete dataset is 450 gigabytes. My God. CC matrix contains previous versions of mined instructions. Previous versions of mined instructions. I'm not sure what this means. 2 ways to access it via the Hugging Face Python datasets library. Okay, so guys, what we can do is maybe, I don't know, scope down the initial training to a couple of languages from the same family group and then use this for the source of mine data and just download the public data from the NLLB branch of AirSec, and then we can start with that. They also use back translated data. I'm not sure what they've done with that. Maybe we can I should have opened up that issue and just asked about back translated data now. How did I think about it? gzipped tab delimited text files for each direction. Each text file contains lines with parallel sentences. The number of instances of each language pair can be found there. Okay. We'll grab this one. Check the raw version instead. Let's check maybe Serbian, Cyrillic, and then English, Latin. Sentences first, sentences second, laser score, language ID for first, for second, source, second source. The lines are sorted by laser score in decreasing order. As an example, translation, score, source. Okay. The data is not split. Given the noisy nature of the overall process, we recommend using the data only for training and use other datasets like floors for the eval. The data includes some development and test sets from other datasets such as Excel sum. In addition, sourcing data from multiple web crawls is likely to produce incidental overlap with the other test sets. Okay. This is the first time I see this license. Let's see what this one means. Okay, let's see what this license is. What we can do is I would love to download Okay, so this is actually for commercial use. That's amazing. Wait. Is it possible? Okay, this is amazing. We'll literally have permissive source of bytext data. This actually makes it much easier for us to replicate the project. This might be easier than I thought. Mining was the part that was actually scaring me a lot. Okay. I guess this is the implementation so that we can download the data easily. Okay. Are there any caveats? Hey there, Adi. I'm trying to think about the data collection process. It turns out the bytext data is already mostly readily available because LNAI used the metadata that was open sourced by Meta, and they've collected the data set themselves and they've released it under a permissive license. I'm gonna try and kick off a smaller language run, 600 million, and see how it performs over the night, and then see what to do about the evaluations. I'm not sure how the evals look like in the FairSec code base. We're gonna see that in a couple of hours probably. Mm-hmm. Yep. Is this a person from Meta? Okay, he did work at Google and still is, sorry, at Facebook. Okay. It looks like this has been merged already, so we don't have to worry. Let's see, what's this? Okay. Let's try and run this. Just download a couple of language directions and see how the data looks like. And then we can maybe start the downloading process in the background. Let's skim through this. Yeah, let me just skim through this README here, see whether there is potentially something additional, useful information. Okay, so they just removed the what? The target language. Okay. See whether I have transformers installed somewhere. Fair sec. Is that the name of Hugging Face library? Yep, I think it is. Pip install transformers. And then after that we can just run, actually we just need datasets, right? Pip install datasets. That should be the line. Of August. Okay. Two gigabytes. Look at that speed, guys. That's called when you have optic fiber. Blazingly fast. Okay. Let's download that. We can maybe just train on, worst case, we can just train on permissive primary datasets and also just use bytex, which is permissive. So we should have enough data to train this and then just release the checkpoints. We are still in the process. We didn't even start training. We're gonna start training soon, I think. How did you try and run some of the evals, like on some of the evaluation datasets, like floors, or did you just try it yourself and did a qualitative analysis of how it performs? Asking to Mikal. Okay. There is something so soothing about looking at the progress metrics and downloading data. Let's see what's going on Discord. Yeah, only thing better is decreasing the validation loss. Okay, we are almost done here. Thanks a lot, Sergey. We're gonna keep on bringing amazing people over the next weeks. We will have Neil Stamos from Cohere, Director of Machine Learning there. We will have Goku as soon as he gets the internal approval. I've been postponing that talk for many weeks now, as you probably saw in the server. But like in general, we'll have people coming up. Tim Detmers will also join us in September. Luis Castricato from X Stability AI and Carper AI. So a lot of cool people will be joining. Boris Daima as well, Dali Mini. He'll join us in September as well, I think. It's gonna be fun. Okay, this was slower than I thought. What is it doing exactly in the background? Processing what? Extracting, I guess. I should have set the download location to be somewhere here. Let's see what happens. So after we have this data, we can start running the sharding and binarization. I've already went through that logic and I managed to run it before I even started these streams. So it should be fairly easy to get everything set up. Maybe we can see how did they choose, how did they train the smaller checkpoints? That's an interesting piece of information. And also, what did they do with the back translated data? Let me see whether I can find some information on that front. A helper script to perform back translation can be found here. It will take a corpus that's been binarized using Stopes prepared data and back translate all its shards. Please check the back translation README file for further guidance on how to run this helper script. Data that has been back translated will then need be to extracted into a parallel corpus. The script extract parsec BT automates this task. Further information can be found in the README above. Once back translated data has been extracted, it can be treated as any other bytext corpus. Okay. Interesting. How much did they use it? What are the percentages? Okay. number of lines. If direction is from a foreign language to English. Kicking off back translation. Okay. And then S batch, job name, GPUs per node. Okay. So this is just submitting to Slurm. I've set up Slurm on my Ubuntu as well, so we can run this locally as well. Okay. What's the expected number of GPUs? I think they mentioned 1. Okay. So we can easily run this locally. It's just it will take a lot of time depending on... Okay. Check the back translation. README. Okay, I've never seen this README. Let's skim through this README and let's see. Okay. The script takes a binarized, sharded, monolingual corpus and back translates it. So it's a binarized, sharded, monolingual corpus. The script will look for the binarized monolingual corpus under there. Okay, we split the monolingual corpus into shards. As jobs on Slur may fail or be preempted, and this allows us to restart individual shards when they fail rather than having to redo the whole corpus. The script will take care of rerunning any shards that are incomplete. Okay. Before running the script, please make sure you populate these variables in the script model. The list of languages. We can start without the back translated data, just see. I'm not sure how much data we'll need. The list of languages supported by the model in the same order they were passed during training on FairSec. The path to the monolingual. Okay. Example command. We specify direction class and then we specify the languages. Is this one called here? I don't think it is. Takes the shard outputs and extracts a parallel corpus from them. Example command to run locally. Extract local run directions. Strip original tag. Okay. Base folder is where the script looks for BT shard outputs. We'll place the filtered outputs. Tells the model to perform SPM decoding using the provided model on both the original and back translated text. Okay. Extract Moses BT. What's this? Analogous to extract versec BT above, but for data translated with Moses. It can additionally perform some very basic Moses specific filtering based on the ratio of copied tokens. Okay. Count IDX. Utility script to count the number of sentences in a versec binary dataset. It's used by the generate back translations to figure out which shards of a corpus have been fully back translated. Okay, fair enough. Just to get some feeling for what's going on there. So guys, we have byte text via LNAI. We can do back translation ourselves. I'm not sure which checkpoint they use to do the back translation, because it's kind of chicken and the egg problem, right? We don't have the checkpoint, so how can we generate the additional back translations? I did read the paper, by the way, all 100-something pages. I forgot some details, obviously. Extract versec. Process language. Jobs. Main. Okay. We don't have to dig into it too much right now. Oh, this is still being processed. There is a lot of examples, apparently over 10 million. Okay. We can focus a bit later on this. Okay. Let's open up the paper. 600M. Did they just distill the 600M? If that's the case, did they distill this one from Okay, they did. They actually never trained on 600M per se. They just distilled from the mixture of experts model. Okay. I know I can run 1.3b on my system if we manage to do model parallel. Training. Okay, fair enough. Human-centered, low resource language translation, languages. Modeling, evaluation, bringing it all together. Environmental impact. Preparing the data. Let's see this. Preparing the model. 3, 4, 5, 6. Let's kind of skim through these pages to understand a bit better about the data set preparations they have done. Just as a recap. Okay. Let me just go quickly stretch my legs and I'll be back in a couple of minutes. I'm gonna grab some water as well. Be right back in 2 to 3 minutes. Grabbing some water plus stretching. Okay, I'm back. Let's continue, guys. Let's see. This is still working, by the way. 14 million examples. I didn't expect that big of a corpus between English and Serbian. Although I guess it's by text, so it's mine data, so who knows. Preparing the data. Okay. We describe how we aggregate various data sources discussed in the previous sections and augment with additional data through back translation. We experimentally demonstrate the advantages of leveraging large-scale mined and back-translated data to significantly improve the performance. Overall process described in figure 33, which is where, okay, primary mined and then monolingual. Okay, you see, you need a 3.3 billion dense model that was trained also with self-supervised learning to do the back translation, and then some data filtering to get the final data set. So I guess for the initial smaller checkpoints, we won't even be using this back translated branch, so to speak. Okay. They train a new SPM. They sample a total of 100 million sentences from the primary corpora. Given that most of the language in NLLB are low resource, uniform sampling would overrepresent high resource. Okay. We apply temperature sampling, which effectively downsamples high resource languages and upsamples low resource languages. This results in a more balanced distribution of samples over all languages. Okay. To validate the quality of the SPM, we first examine the rate of unknown tokens for each language. We observed that even after using a high temperature for sampling, certain languages such as blah 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 had higher unknown error rates. Okay. Due to the very large character set of their scripts. We further upsample those languages by a factor of 5. Okay, thanks, Sergey. Good to know. Good to know. I will do that next time. With these modifications, the unknown error rate for all languages is below 1%. Nice. Tokenization rate, or the average number of tokens per sentence for each language. Okay, fair enough. We chose a vocabulary of size 256,000 to allow for enough capacity to represent the wide spectrum and large number of languages we cover. As we achieve reasonable tokenization quality with a vocab size of 256K, we do not train sentence piece models with even larger vocab, as the larger vocab size would significantly increase the number of model parameters. Fair enough. To evaluate with SP Blue, we use this SPM 200 as a tokenizer to better support the languages of Flores 200. We open source this SPM along with Flores. They love using this word. To train our systems, we leverage 3 different types of data. We had a total of 661 sets of primary bytext data. I'm not sure what that means exactly. 661 sets. We saw around 26 data sets in this table 52 before. We chose all English-centric sets when available and also add non-English-centric pairs if they have a low resource language either as a source, target, or both. Table 52, blah, 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 provides further information. Okay. And then there use the mind. They first pick the directions which have XSIM error rate under 5. Fair enough. We've seen the XSIM yesterday, by the way. That's why it was valuable to just go and get some familiarity with laser code base. Or was it 2 days ago? As a further restriction, we added mining data primarily for pairs containing low resource languages. Within a given family or geographical region. Okay. We share the full list used for training. Page 92. Let's quickly skim through the appendix here. Let me just see what this is. They additionally have this curriculum. I remember reading that. I completely forgot about it though. Okay. Back translated data. Provides a form of weak supervision which is crucial for improving translation performance of low resource languages. As we observed in the section, combining back translation data generated from multiple sources improves performance of a translation model. How do they choose which languages to add data for? Let's see. They first train a baseline multilingual neural 3.3b of all the primary bytext pairs and English-centric mind pairs. Okay. We train this model in a multitask learning setup comprised of both MMT and SSL tasks. SSL basically here means they're also using just monolingual data as additional task and hence multitask. So it's not only machine translation, it's also basically just next token prediction using monolingual data to produce the strongest possible model. We find that it is extremely important to back translate with the best possible model, as the quality of the generated back translation is highly correlated to the performance of the model used to generate BT data. Okay. Into English is more significant improvements than out of English. Okay. After training the above baseline model, we select a subset of languages for which we generate the data for. Okay, so when the SP blue is weak, then they pick those languages. Okay, they use this SMT-BT model, the statistical model, bilingual statistical model. I'm not sure what that is. So they select every direction where the floors of the baseline is below 30. So using these criteria, they selected 76 English-centric through the SMT and 261 through the MMT. Okay. So basically they train this powerful 3.3 billion baseline model, including the SSL task, so self-supervised learning, and then they evaluate that model on the floors 200. They take a look at the SP blue score for different directions, and then they set thresholds. So if the threshold is like below 10 or 15, depending on whether we're going into or out of English, they basically, for those, they use this statistical bilingual model, which I'm not sure what it is, to create the back translations. Otherwise, if it's less than 30 and it's not already covered by this statistical model, well, this statistical bilingual model, then they use the strong baseline for back translation. That's kind of the gist of this whole text. Okay. Scaling back translation generation. Okay. Maybe it might be worth asking for the back translated data on the in the Stopes repo. So let me think. The mine data that LNAI Focus open sourced, is that filtered or is that raw? And then we have to additionally do some filtering ourselves. Okay, I guess just by the very nature of you collected a mine data set, you had to set some threshold for laser. It's just not clear which threshold was used for the metadata that they released. Was it also 1.06? And then the length filtering. Okay, let's see this. The concept of length is not straightforward when working with a massively multilingual model due to the inherent differences across different languages. In order to account for this phenomena, we measure sentence lengths based on Unicode code points and apply a language-specific correction factor. For a given language L, the factor is computed. Okay, total length of the floors 200 validation set for language L. Okay. So for mined and back translated data, we filtered out sentences with length ratios above 9. For back translations, we additionally filtered out sentences of length below 15. Corresponding to about 3 words in English, as we empirically found such short sentences to be a source of noise. Okay. Is that already used here? Let me just see one thing. Fairsec. Let's open up. Let's open up Stopes. Filtering. Let's see, the length, maximum length ratio is 9 and minimum length is 5. Okay. I think that's the thing they just mentioned, right? Okay, LID filtering. Toxicity filtering. Dedupe. Okay. Okay, we're gonna wrap up soon, guys. And then we'll continue later in the evening. Let's just read a couple more sentences here. And then we can continue a bit later. To keep on downloading the data, I'm gonna run some dataset download in the background so that we can start sharding, binarizing, processing that, filtering, all of that, and then start kick off a run of a 600 million parameter model, and just as a test, make sure, like as a sanity test more than anything else, just to make sure nothing is crashing. And then over the next days, we can work on selecting the data, cleaning the data, all of that. Okay, we can actually think we can continue this after the break actually, when we are a bit fresher, especially me, after 7 hours of streaming or something, more than 7. Okay, guys, catch you a bit later. In roughly 2 hours or so, I will start the final stream of the day. 3 more hours. We're gonna go skim through the necessary relevant parts of the paper, and basically, okay, we are here. Let's see what happened here. Bye, Sergey. See you a bit later. Let me just wrap this up. We ran the where is the examples, fair sec. Where is data? Okay, here it is. Here we are. Why did this stop there? Okay, something weird happened. Exception has occurred. Non-matching splits sizes error. Expected. Recorded. Weird. Okay. Okay, we can check later what happened with that. So a couple of tasks. Okay, guys, that's it for this stream. Logging off for this stream. See you in the next one, or whenever you join, guys. Cheers.